Countries in Europe, Asia, and North America are currently evaluating geological repositories for high-level nuclear waste to take the waste that comes from nuclear power plants and isolate them in the subsurface where they will not be a danger to humans or the environment. Over long periods of time, it's possible that radionuclides will slowly leak out of the engineered barriers in the repository and into the rock surrounding the repository. And those rock layers then form the final barrier to release to the environment. So it's necessary to assess the functioning of those geological barriers. And radionuclides can be transported through those rock barriers through a series of interconnected fractures. Water flowing in the fractures will transport radionuclides slowly through the rock layers. Radionuclide transport in the subsurface is a computationally difficult problem. There are a large number of processes active all at once, and also potentially large number of radionuclides that are coupled through decay chains. Southwest Research Institute, using internal money, developed the Time Domain Random Walk TDRW software to address radionuclide transport. TDRW uses a unique algorithm, a particle-based algorithm, that's extremely robust and efficient. And this allows geological barriers to be modeled in much greater detail, much more realistically. TDRW is available as a standalone computer code or as a software library. This is important because a lot of organizations have their own legacy codes that they use to evaluate other aspects of the problem. And the TDRW library could be linked to those and fully integrated into the computational workflow. TDRW is based on a particle tracking algorithm where particles represent packets of radionuclide mass. These are then moved through the system with a series of rules that are derived from the underlying physical processes. The main advantage of TDRW is that it's extremely efficient, and this efficiency makes it possible to model a great number of transport pathways instead of a single idealized pathway. The principal application of TDRW would be the evaluation of nuclear waste repositories. The other important application is in the assessment of risk associated with sites that are already contaminated with radiological waste. Another potential application would be to model hydrocarbon migration to the subsurface. TDRW will make it possible to evaluate potential geological repositories for nuclear waste in a much more realistic way. And this is important for gaining public acceptance of new nuclear power plants as an alternative to fossil fuels.